Welcome everyone to the latest episode of Listening to the Wind, IWSA's weekly interview series. And I'm delighted to sit down today with Roger Eggers, Senior Project Manager and Maneuvering Knowledge Coordinator at MARIN, the Maritime Research Institute of the Netherlands. Roger is a naval architect, marine engineer, and has been working on hydrodynamics and maneuvering for the last 13 years at MARIN. One of Roger's specialities or special areas of interest is, of course, wind propulsion, and he will be chairing the Natural Propulsion Seminar this year on the 31st of May. Roger, welcome to Listening to the Wind.
Thank you very much, Kevin, for having me.
You're more than welcome, and I'm really looking forward to seeing your presentation. So without further ado, I'll hand that over to you, and I'll see you on the other side for some interesting discussion points.
Yeah, thanks again, Kevin. Yeah, people can refer to me Roger in short. I realize my name in English sometimes is a little bit difficult. Indeed, sharing the screen here. So, prepared some material to describe MARIN's contribution in wind propulsion. And as you mentioned, I've been active in that for most projects at MARIN. So you described my field of, my discipline is aerodynamics and maneuvering. With wind propulsion, naturally the aerodynamics comes in. Let me start off very briefly to describe MARIN in general. So we are a maritime research institute, and I think very special in MARIN is that although we're very specialized in this marine application, we cover this in many disciplines. So simulations in early stages of projects, doing scale model tests, that has been the starting ground of MARIN, still very important in verification. Simulators to train certain operations on board, and then finally monitoring. And having all these fields active is very interesting because, of course, there's many feedback loops going back and forth. What we learn in the monitoring, we can apply again in simulations. And of course, having all this knowledge available can be a huge asset in developing of designs. So MARIN, we are an independent institute, foundation effectively. Already with a long track record. We work for industry, government, civil and defense, so across many different markets. We collaborate in many JIPs, joint industry projects. We're about 400 employees active throughout the world to provide our services. So getting quite quickly to what we do for wind propulsion. I'll get to some research topics shortly after this, but specifically providing services to project development, so owners or designers or yards developing concepts for wind propulsion. Firstly, a very interesting service is to do feasibility concept studies. So doing independent exploration of saving potential, looking at various devices and arrangements, various routes. We use simplified methods in this, allowing very quick turnaround times. And this can be very helpful in supporting choices in concept developments. So looking at retrofit as well as new build. And I think very important in this is that we have an independent position. So we are not tied to any specific provider of a wind propulsion technology. We have an overview of all technologies, all relevant technologies, I would say. So this is very interesting in initial phases of concept and design development. Then going further in the timeline of a project, then often follow-up phases looking at optimization or verification. So as we may not always be involved in the earlier phases of projects, this can either be involved in the later on, even if we're not involved earlier on. So the core of this is likely on the wind propulsion itself, savings, but it can be anything involving all other MARIN services as well. So very logical is to look at aerodynamic performance, hydrodynamic performance using CFD studies or model tests. Another very interesting topic is, especially if we increase the amount of wind propulsion to match the wind propulsion with a propeller propulsion line that is suitable for that. The loads on the propeller line can start to fluctuate quite a lot when introducing wind propulsion. And that is not obvious to remain efficient with a conventional propulsion line. So often some things need to change. Compliance and operability, considering maneuvering and course keeping. There is potential for larger yaw oscillations, for instance, or yaw moments being introduced into the vessel when installing wind propulsion, and these topics can deserve some specific attention. Void simulations, the present state of the art in the market is often to simply optimize the ship to seek the best benefits for the wind. However, considering sea keeping, for instance, there are certainly constraints and we can add value there. And in the final stage, when a project is really launched or a retrofit is implemented, onboard verification using trials and monitoring can be, again, especially with the independent focus, can be very interesting. Some of this is illustrated in the description of the research that is following now. So we apply these services in direct projects, owners, designers, shipyards or suppliers, trying to make best implementation of technology, wind propulsion. We also look at it in a more broad perspective. MARIN has a research program, and the strategy around that is very much around shift of sustainable use of the oceans. So what you can see here, we're looking at floating wind, so beyond the fixed foundations. Floating energy islands, it's also about exploiting the sea in a sustainable way. And then towards the bottom, you see wind propulsion ships is really part of our research within the broader context of meeting the IMO ambitions, getting to zero carbon vessels. So that also involves other power systems, other energy on board, fuels, and the whole infrastructure around that. But wind propulsion, as part of that, we see the potential, and as MARIN, we see a role to facilitate that with research so that it can be implemented on board in a reliable and robust way with proper predictions. So what areas are we focusing on there is firstly, of course, the aerodynamics. So you see some illustration here, looking at the onboard application with the incoming flow, modeling the propulsion contribution, not only based on wind tunnel tests, although they're very important. There are skill effects. We are accounting for that and making advances there. Also in a way how to best implement the propulsors on board, of course. Some pictures there is mainly done using CFD. Then looking at the hydrodynamics, the load as well as the inflow to propellers changes. A ship is developing a leeway angle generally when introducing wind propulsion, so that that puts the load on the propeller changes, so you have to operate it slightly differently. As well, there can be noise and cavitation impacts. So this is a line of research. As well as looking at the hull form, these things go a bit together. The hull form itself and also appendages, as the ship develops a leeway, that generally means that there's also increased resistance on the hull, that you would like to reduce, especially for the more advanced or the larger wind propulsion contributions. So then unsteady performance. Predominantly research is focusing on establishing the savings, and that is mainly done in looking at steady conditions. However, ships are not always in equilibrium. They need to maneuver, they need to sail in waves. And there are some specific interesting points. I mentioned the course keeping with less flow induced by the propeller on the rudder. That is a point of attention. At the same time, some wind propulsion devices can add significant roll damping contributions, so there's also positive effects. These things, especially again for the more substantial introduction of wind propulsion, can be important areas to research, the points that need specific attention or where benefits can be had. So finally, all the topics before, we do put them back in steady performance predictions, which is still a very essential tool to look at the optimization of ships. For instance, in this illustration, you see the impact of varying the length over beam ratio of a ship, and then having the impact on the grams of CO2 emitted per ton nautical mile transported. So there's a general workflow in place that we follow for this kind of work. Then, voyage simulations mentioned by many. That indeed, for the substantial installations, this can be really important to tap the final savings to make sure that you go to the areas of the highest probability of wind. There is, however, still many areas of improvement in these simulations. Quite often they're implemented looking at the hindcast databases, but doing the routing, having this knowledge already. So the uncertainty of prediction is often not implemented. This is a feature that we are working on. As well, generally, we apply also constraints for the maximum motions that are acceptable. You generally don't want to go with a ship to head for a storm, even if there's favorable wind. A captain will normally not like to induce also the biggest accelerations, screen water events, or slamming impacts. So we have tools for that, that we're advancing, both in the simple case that you see on the right-hand bottom, blue route, where you can explore with fixed routes, as well as doing comprehensive voyage simulations where the route is really optimized. Finally, onboard monitoring. So this is directly a service, but also we're looking at understanding really the wind field above a ship. Contrary to sailing yachts that have relatively their rigs extending far above the superstructure of the ship, many devices implemented for wind-assisted ship propulsion on board commercial ships, they operate in the zone of influence of the ship itself. So the wind is disturbed. Already there's a boundary layer due to the surface of the sea, but also the deck edges, and the structures on deck, they deform the wind. And knowledge of what is actually the effective wind field encountered by wind propulsors is a field of research where recently we have been introducing a LiDAR measurements to shed more light on that. So that covers some examples of the research that we are doing. Then, as you mentioned, Gavin, we see our role really as MARIN. We have a mission to both help directly in specific projects to make the most out of a specific design. However, at the same time, we work more at the full industry level, where we try to seek collaboration and work with the industry together to move a full field forward. So as part of that, we organize the Blue Week, which is running since 2012. We combine shipping and offshore activities where the focus is really on the sustainable use of the environment. It's an efficient combined public, but also closed project event. And especially as soon as we have physical attendance becoming relevant again, this helps people traveling to one event, sharing results in public seminars where there's project results and also the opportunity to launch new initiatives, but combining that with usually closed collaborative joint industry project meetings, having that together in one team provides a very efficient get together for a yearly following progress in this field. We have several teams, of which I highlighted the most relevant one for the shipping and the wind propulsion here. So in the upcoming edition on the Monday, 31st of May, we have the National Propulsion Seminar. Effectively, that is mainly on WASP, so wind propulsion, although it's open to any natural resource that can be used for wind propulsion. However, also very interesting is the Tuesday, June 1st, where we focus more broadly on zero emission, focus on the fuels, but also the full infrastructure necessary on ship to get to zero emission ships. So the two of them are finally really necessary. Please register, go to blueforum.org to join us in this nice event. Then a bit more specific again on the wind propulsion. MARIN, together with ABS, American Bureau of Shipping, have recently concluded the first WISP project, specifically on wind propulsion, where we try to really alleviate the barriers on wind propulsion in a collaborative fashion. So there's a collaborative project where participants and partners joined us. In the first project, we delivered recommended performance prediction methods, which we derived based on sensitivity analysis on a few cases of ships. So having tangible data in hand, you can see the cases that we handled at the bottom. Also looking at an inventory of rules and regulations. And the results of that have been also submitted as papers to the MAPC 76, considering the EEDI. I see you popped up again, Gavin. So getting to the last slide on this WISP project, we will shortly be starting a follow-up. So we started on this topic, but there's many extensions and refinements to be made. So firstly, we'll be looking at additional devices to be covered in the recommended prediction methods. Also covering validation using onboard trials and monitoring. And then we see that maneuvering and course keeping is coming up as potentially a challenge for the more the larger wind propulsion contributions, and how to handle that efficiently, how to make best use of the forces is a point of attention that we wish to cover. This is starting really quickly. So we have actually a preparation meeting starting this Wednesday, May 19th. Gavin, a question to you, whether this interview will be actually live before that. But people can also jump in for the kickoff, June 4th, part of Blue Week. Please contact us or have a look at the website mentioned below. Participants to this are very much welcome. That actually concludes a quick overview of MARIN activities and services. Gavin.
Yeah, thank you very much, Rohit. And we will try to get the interview up by the 19th if we can. No, really interesting overview of everything. And I'll just touch on the WISP project first of all. I just wanted to find out what was the real driver behind initiating the WISP project.
Yeah, we like to refer to the very comprehensive report by CE Delft that was commissioned by the European Commission. I think that was published in 2017. that highlighted both the potentials but also the barriers for the uptake of wind propulsion. And it was mentioned there, and I think it was just a general sentiment in the market, that there's a lot of uncertainty still on the savings and the technical information around wind propulsion. So we wanted to work in this area to basically put down a start of a standard that can be used to predict wind propulsion, and by having this in place, to increase the confidence of owners, operators to make investment decisions. Also generally to have a look at the rules and regulations, to which there was some uncertainty. What are actually the steps that you need to follow to make sure that you have a project that is also fully compliant to statutory and class regulations. So that was the starting point, and I guess it is still the main driver to start to follow up. Although things have evolved, we get, I think in general, the industry is maturing, so the frontier is pushed forward a little bit.
Yeah, absolutely. And actually on the plan is to actually revisit that EU research document and sort of check the progress and look at the strategy going forward, not just on the technical front, but on the market and policy fronts as well. So watch this space, and we'll be doing a little bit more work on that. And Blue Week has been running now. I think on your slide it said 2012, which is amazing how quickly that time has gone. What changes though over that nearly a decade? What changes have you seen relating to wind propulsion for sure, the natural propulsion sort of wider aspect, and also decarbonisation in the industry?
Yeah, well, we started small. So the start of the Blue Week was really the natural propulsion seminar. So that is the element in the Blue Week that has also the longest history. And I would say in the beginning, it was really a push by, let's say, maybe you could say some activists that were really pushing their inventions. Some of the contributors were really the inventor type. And I think at that time, the wider industry, they were maybe already interested, but not maybe taking it fully seriously. And of course, the environment over this time completely changed. I think pretty much everybody now acknowledges the need for decarbonization.
Yeah.
And we have seen that maybe some of the early organizations that engaged and that presented at Blue Week, they have matured, and some of them have developed from startups in quite credible companies. So and taking fully seriously across the industry now. So that is really a nice development to see, and it's nice to have this continuity that those early organizations that engaged with us, including yourself, Gavin, are still with us.
I think not in small part because of the natural propulsion seminar. Actually, I remember, especially in those early days of groups coming together, exchanging ideas, real pioneers in the field, but also starting to make tie-ups and relationships with other groups and other, if you like, other stakeholders in the industry. So I think you can certainly get a feather in your cap for helping to stimulate the market and the development of the technologies as well.
Thank you very much. And I think that is also a collaborative effort. You yourself, you have embraced the event with the International Windship Association, having the annual general agreement, annual general meeting as part of Blue Week, and we really promote that other projects, also those where MARIN is not involved, to have their event as part of the wider Blue Week, the Blue Forum,
indeed,
that we like to call it.
And indeed.
So the SAIL project, for instance, was initiated with stakeholders mainly engaged in the in the Blue Week. And we have the pitches still as part of the program. So indeed, stimulating and providing the platform to start new developments is part of the Blue Week. I think that makes it unique.
No, absolutely, absolutely. And I'm gonna sort of bring it out a little bit on a wider perspective. Yeah, we were talking about decarbonisation and the fact that there's a realization in the industry, and I think it's either the need to decarbonize or the inevitability of decarbonising. But do you think we're actually moving fast enough as an industry going forward? Are we going to decarbonize in time? Do we have the tools available to do it?
Yeah, very good question. I'm not sure if I can give the full answer to that.
If you can, you're going to get a big bag of money, I think, from a lot of people. But
yeah, it is of course a really complex process. And as MARIN, we're mainly working, is the technology ready? But there's a big question also, is the infrastructure onshore? Of course, wind propulsion is certainly maybe an important part, and it really depends on the operational profile of a vessel and also the area where it operates, considering the wind, how relevant it is for a specific vessel. So the fuels are also really important, and of course the supply. Yeah, I guess it's anybody's guess how the investments are really playing out to make that all work and to supply the fuel and the energy needed for shipping to reach its ambition.
Yeah, no, I think that holistic view, and definitely that comes through whenever I attend Blue Week, is that sort of wider holistic view is really important. We have some mechanisms coming into shipping, and obviously these have been debated quite extensively in the WISP project. We have, of course, maybe an update or an upgrade of EEDI, but now we have the EEXI, the CII coming in, and also at a later stage, rather than a regulation, we're going to have some form of market-based measure coming in and maybe backstopping all of these. Which of these is going to be the most important, do you think, to actually maybe engender the technological change that we need to see, or the embrace of technologies, but also to really bring decarbonisation, lock it in and becoming mainstream, if you like?
Yeah, well, on the short term, relatively short term, we see the EEXI being implemented, and I think everybody's aware that a large share of the worldwide shipping fleet doesn't naturally comply with the EEXI requirements. So that's the initial push, where wind propulsion can help as one of the options if you don't want to derate the engine, which is probably the most easy measure to take. If you want to still keep your speed and your transport merit up, wind propulsion can really play a role there. Yeah, then going forward, the EEDI and the EEXI is implemented now, and the targets evolving over time. That is not going to bring us to the zero emission ambition that IMO is implementing. So looking at the path now, it's going to be the CII and the criteria around that. So specifically tied to the actual bunkering of vessels. That is due to bring, I think, I see that as the main measure to bring shipping to the zero emission future. But of course, a lot in the regulation is still to be implemented. As you mentioned, with the WISP project, we have been focusing a lot at EEDI, and in a large part, EEXI is similar. So the regulations around that, making that more transparent and more realistic, has been our aim. Possibly for ships going forward, that is not going to be the main driver anymore. So it is simply going to shift to operate in the most efficient way. So then meaning to fully understand what is the operation is going to be even more important. And we want to bring that in already in the follow-up of WISP. Going forward, it's going to be increasingly more important.
And in that follow-up WISP project area, obviously something that's rising up the agenda is the primary wind, the wind as a main propulsor. Now, obviously there's we have the minimum power requirement on vessels, but that brings in some interesting aspects. Is WISP 2 going to be covering a little bit more or expanding a little bit more to looking at those primary wind vessel designs?
Yeah, I think the realistic answer is we do depend a little bit on cases. So we like to not only do scientific work, but the participants stepping in, they contribute their cases. We do protect, by the way, for people considering that the data being brought in.
Important.
Not a full disclosure of all project confidential information. We take it a little bit, have a layer higher up, and like to call this a pre-competitive project. But certainly already in the previous WISP, we actually have proposals to the MEPC to consider wind propulsion in the regulations to look at two tiers. So the methods presently being implemented are certainly only suitable for modest assistance. As soon as you go to higher percentage of savings, then the hydrodynamics, the ship moving with leeway through the water, the propeller propulsion being loaded at off design points are really becoming important. At present, that's not covered, and we would prefer to implement that, which means that you already go to larger percentages. Yes, primary wind propulsion, we would certainly like to have a case on that in the follow-up project.
So that's a call out to all of those members with the primary wind propulsion designs and projects going forward.
I think the first summary is certainly beyond what is now presently in the regulations. Whether it's going to be full wind propulsion depends a little bit on the play out of the participants finally engaging. And we invite everybody to participate in the preparatory meeting to that end this Wednesday or at the kickoff June 4th. Please come to us.
No, that's great. And I'm going to finish off on a sort of discussion point, which is a little bit of a loaded question, but are there any significant sort of safety, engineering, or sort of technical barriers to wind propulsion, or are we entering into a period more of optimization and adapting designs and the sort of facilitation of systems? I know that's a really big question, but I'd really like to hear your opinion on that.
Yeah, I think that's a bit of a nuanced answer that you get there. Yeah, I think across the industry, and also shown by mainly the work of ABS in the previous WISP project, looking at regulations, and there are certainly some elements that need some attention. Visibility, radar, blind sectors, and so on. Most of that seems all to be can be solved either in adaptations of relatively small adaptations of ship designs, possibly some streamlining of regulations coming up, and I think for that reason we'd like to implement it in the WISP 2 project is course keeping and maneuvering. Where there is really some uncertainty how to apply the present maneuvering standards by IMO, the zigzag and turning circle maneuvers. Were of course the requirements were never stipulated for wind propulsion, so there's some question on how to interpret this. Also, simply with wind propulsion, you do introduce moments that put the vessel at a specific balance. So it is something to have a good look at to see how we do that. Also the course keeping in waves, and it may in fact have some impacts for the larger savings or even primary wind propulsion ships. They need to account for that to make sure they keep a sufficient course keeping ability in stern quartering seas and wind, for instance.
Sure.
Having said that, I think it's all solvable, but requires some work. So yes, certainly some challenges, and by the way, also some benefits of wind propulsion. The roll damping introduced by the especially by lift sail-based or wing sail-based solutions can also be a benefit to ships as soon as you accept a small heeling angle. Yeah, I think that is the nuanced answer to your question.
No, that's great. That's great. Now I'm gonna move on to a small quick fire Q&A session. So this is a not quite a yes or no answer, but a very short phrase or sentence. So I'm going to give you 4 or 5 of these, and we'll rattle them off very quickly. So what is the size of the MARIN team that works on wind propulsion?
Yeah, presently roughly 5 people. I would say that a large time of their day is spent on wind propulsion. Mm-hmm. We don't have a dedicated team, so these people are flexible to move to other topics as well. Yeah, with our aerodynamic and principally, of course, hydrodynamic background, we have a larger pool of people available that can also work on the topic.
So building up expertise, that's great. Now, how did you personally get into this wind field?
Yeah, I guess like many people, in my free time, I really like to sail. I've been doing sail races a lot, mainly windsurfing. So yeah, it comes from my private background that I like it. Also, yeah, I simply have push. I think it's in the title here in the sheet, Better Ships, Blue Oceans. For me also, reducing the impact of shipping on the climate is something I like to work on. So opportunities came around. So that's also a matter of simply some luck that I got involved in this. And yeah, so I'm happy to
grabbing the opportunity.
Then I kept on to the topic. Yeah. Sorry?
Yeah, grabbing the opportunity when the wind was blowing.
Yeah, yeah.
Fantastic. What is the most difficult issue regarding wind propulsion that you've had to deal with in your time at MARIN?
Yeah, I guess it is a bit of a luxury problem, but as MARIN, so we are very specific in the maritime field, but we work on the designs, we work on operations, we work on simulators, and we have, I mentioned some of the overview of the research. It's very easy to lose focus. So we're working on many different topics at the same time. I guess this is one of the challenges to keep focus and to decide. And to that end, we had a workshop following WISP to get some input from participants engaging with us to pick the topics to say, okay, this is really the most important at the moment. I think one is obvious, to look at the savings in steady conditions. That is always going to be the main tool to optimize ships, but especially around that, there's so much to research, and we have to be careful not to move too much to really niche areas, even though later on may become really important, but
right
in the short term.
So keeping on message.
Yeah, keeping on message. Yeah.
Right, right. And it sounds like an exciting time, and I think it's very much an exciting time in shipping and specifically in wind propulsion. So my last question is MARIN, and in particular the wind propulsion team, if you like, are you recruiting at the moment?
Yeah, very good question. Very specifically, no, we're not specifically recruiting for the wind propulsion team. However, you can see there is a vacancy at the moment for a project manager, specifically for well, towards zero emission, so the fuels and the infrastructure on board. But as mentioned, in generally, we don't have a very strictly defined team. So we are, as MARIN, we are very well capable to scale. We have a large pool of people that, with their background, they with a small internal training, they can work on the wind propulsion. Right. So we are with I think as yourself, with great anticipation, we are awaiting the scaling up and seeing the amount of projects increasing as we see already now. So yeah.
No, I think on that point, I think on that point, on that positive point, is a great way to sort of finish the Q&A. Now, I absolutely agree. I mean, I think all the groundwork has been laid over the last few years. We're starting to see the beginnings of that sort of a scaling, or the foundations of the scaling up of wind propulsion coming through. So I think the next couple of years is going to be a really exciting period. Now I'm going to give you just a 1 minute kind of a takeaway statement opportunity. So I'm going to be quiet for a minute, and I'll hand it over to you, Roger. Just give us your what should we take away from what you've been talking about today?
Yeah, firstly, we didn't even touch that, but I think wind propulsion as part of a bigger toolbox can be really useful to decarbonize shipping, although dependent on the specific ship operation and area. So in that, we like to assist owners, operators, shipyards, designers. We can work directly for your project, helping you with independent advice or verification. And we specifically invite people to engage in our Blue Week, as you just mentioned, and the WISP to joint industry projects where collaboratively we can all move together as an industry to move the wind propulsion forward. And finally, Gavin, thanks very much for the opportunity to with this way and this interview to highlight the MARIN research. Thank you also for your very pivotal contribution with the International Windship Association.
Well, that's my pleasure, and I think the word that I really take away from everything that MARIN does is collaboration and a collaborative approach to this. And I think, you know, if we want better ships and we want blue oceans, that's the only way that we can go. So on that note, Roger Eggers from MARIN, I'd like to say thank you very much for sharing what MARIN does and the projects that are coming up as well. And thank you to the audience for joining us with Listening to the Wind, and we'll have another episode next week. So thank you again, Roger.
My pleasure.
Thank you. And everybody, please stay safe, stay well, and fair winds to all.